Companies today rely on outdated sensing capabilities to take high-stakes critical decisions. We utilize quantum sensors to enable actionable real-time gravity data upon which you can take critical decisions in the moment. The problem that we have with conventional sensing is that most of these sensors, and especially the gravity sensors, they're exceptionally sensitive to environmental noise. The technology that we have, it's the noise cancelling headphones for underground surveying. You can take this data and you can save people time, save people money, makes people safer. Void detection, as you can imagine, has got significant impacts for dual use applications, finding tunnels, finding voids, energy deposits, we can find aquifers. This isn't a straight down sensor, this is gravity, this is a force of nature that we're measuring. It's a data layer that you cannot buy for any money.
Hey everyone, thanks for listening to another episode of DIB Innovators. I'm Dave Graff. Today I'm joined by Tony Lowe, CEO at Delta.g. Tony spent his career turning frontier hardware, quantum computing, autonomous systems, and now quantum sensing into real-world products. Tony, it's great having you. Thanks for joining.
No, thanks very much, Dave. Great to see you.
Yeah, we met at a great tectonic event down in Austin, so that was fantastic. And we decided to get his word out. So let's start with your path. I mean, you have a very unique path, very diverse path. Talk to me about, talk to our listeners about, where you start your career and what started pulling you kind of into deep tech hardware companies.
Yes, so it's an interesting career arc. So I started out in corporate IT and so sat in the security space a little bit as well during that time. And it was great, and I was managing large scale IT projects, but I was looking for a little bit more. Whilst I was at Jaguar Land Rover, the then CEO of the business, Dr. Ralph Speth, wanted to integrate connected car products, and there was also some upcoming legislation. So myself and the then CTO of Jaguar Land Rover, a guy called Mike Bell, co-founded what would now be called a corporate startup. It was effectively, we were given money, given funding directly from the CEO and given a top-down push. So the directive from the CEO was, we will integrate this technology into our business, but we were completely removed from the decision-making cycles of the business. And we were allowed to pull together a team, a small, compact team. So we delivered the entire connected car program across Jaguar Land Rover, which is a 40,000 person company with 18 people. That's 18 people. And that was really sort of pulling the best people out of the business and making sure that we did everything from sourcing the hardware, the software. We wrote, the CAN software. We designed a smartphone app. We designed the handover documentation. And then we get together the teams that we delivered it to US, Europe, Russia, China, all the really easy places, of course.
And let me just stop for a second, just for pronunciation, because I had trouble. Jaguar, I say Jaguar. Jaguar Land Rover.
We always say Jaguar, you see, so that's a slight difference in the Americanisms.
I just wanted to clarify that.
Tomato, Dave. Tomato.
Yeah, the pony's in England right now. That's where you guys are based. So that's some of where this started from. And tell me again, what were you doing for them? What was the spin out to do to make it connected, to connect your cars? And when was this?
Yeah, so effectively there was some European legislation that was coming in, and most of the European car brands already had some form of connectivity in the vehicles. So there was a new European legislation that said that every new type approved vehicle had to have the capability, if the vehicle crashed, to contact the emergency services. So know where you were, what direction you were going in. So for instance, you hear about people who crash into some woods and that they're not found for days. So that's what they wanted to do, get ahead of first responder stuff. So there was legislation that came in through the European Union, which we were part of at the time. So of course, if you are putting that level of technology into a vehicle, you're carrying some significant additional cost. So what the vehicle manufacturers want to do is they want to recoup some of that cost, because of course, what you're getting from the vehicles that you never got before was data. And all things are a data play. All things are a data play, including what we're now doing at Delta.g. We have an amazing quantum sensor that I'll tell everyone about in a moment, that gets a data layer that you can't buy for any money. But at the end of the day, if you don't take that data and then package it into actionable insights that is usable and solves a customer problem, it's a waste of time. So this really introduced me to the idea that you can put this technology out into the world. You can take this data and you can utilize that data in a way that saves people time, saves people money, makes people safer, however you choose to package that.
Okay. And then how was that working at a large corporate company in a startup mode?
It was extremely interesting because we were given effectively by the CEO carte blanche to work across the business. So we had in our back pocket the CEO card. So we could play the CEO card anytime we wanted. However, what you don't want to do is you don't want to overplay that card. So I think we only had to do it twice in the whole thing. And we would have conversations with the individual business units, and we would say, would you like to do this for us or with us, or would you like us to do it on your behalf? Most people wanted to allocate a contact to make sure we were following process, but then were quite happy to allow us to move forward to do whatever we needed to do. So the fact that we were removed from the business, removed from that decision-making process, and we had the top-down sponsorship from the top of the business enabled us to very quickly do something in a very large siloed organization that just wouldn't have been possible if it had just been put into the normal business. So this is now quite usual in large corporates. They will take teams of people, move them, get completely offsite from the rest of the business, and allow them to innovate. Now, the thing that separates the organizations that are really taking advantage of this from those that aren't is, what do you do with the output that the people who you've given this level of freedom come up with? Do you take it and actually implement it in the business, as we did at Jaguar Land Rover? Or do you say, that's nice, that's interesting, and just put it to one side? So I think that's what's separating out the large corporations today. From my observations, it's how much of this new technology and these new insights that they will actually carry through to be implementable business processes.
Right. Okay. You do see a lot of those innovate. I mean, when I was at Skunkworks, that's the idea, right? You had the small unit innovation group.
You've worked for the poster children of what happens when you take a group of highly motivated, high agency people, put them completely away from the main business, and then leave them to get on with stuff. I recently read the book, actually, the Skunkworks memoir, and it's just phenomenal to read it. Just, everybody was no more than 30 meters from the aircraft, or something like that. It was just the notion that this was put together, sort of in the 60s, 70s, and 80s is great. And it's the notion that I try and bring through today. I mean, I've seen issues where, and again, I'll come to my deep tech adventures in a little bit, but I've seen what happens when you separate people on different sites and they become removed from what's actually happening on the what actually from the engineering, and that just creates a division. And all things that I do now are trying to bring that one group of people together. So everybody's working in the environment. So everybody has their finger on the pulse of what's happening with the engineering, what's happening with the customers, what does the customer need. The customers don't always know what they need, of course. So it's we run value proposition design workshops to ask people, what's the job that you're doing? What outcomes are you looking to achieve? What are the pain points you have at the moment? Start solving pains for people, and then suddenly a bit of magic happens, and you get this two-way interaction. So it's all about bringing together this group of high agency, highly motivated people who will put their shoulder behind a particular activity. And it's all the concepts of we don't have to agree all the time, but the notion of disagree and commit, and having everybody say, right, it might not be the way I'd do that, but I'm going to put my back behind it. You You can move mountains very quickly at pace, and you'll have seen this at Skunkworks. I mean, this is the whole notion behind that. You're knocking planes out in half the time for maybe not half the cost, but being able to deliver things with a you've got a window of time. How do we make this work within that time window? And that's really for me, that's the core of innovation. Restrict the time, bring those people together who've got completely different skill sets, and just watch them out, give them a clear outcome. This is the outcome that we want, and just let the magic happen. I think that's the way to do innovation.
Yeah, it's pretty powerful. Ideally, and I think we're seeing that with a lot of startups nowadays, defense tech specifically, are taking that model, but then they've got the whole challenge of it's just hard to run a business. You've got fundraising, you've got people, you've got different things that, but yeah, that's the goal. That's perfect.
You're absolutely right. I mean, I think it's one thing to come up with an amazing piece of technology. It's one thing to iterate that technology, but what commonly happens is, especially with academic startups, the product is almost the technology is mistaken for the product. It's like, we've got this amazing technology, everybody will want it. So the question I then ask is, because I'm an operator, I come in and say, okay, well, how do I'm former COO at 2 Oxford University spin-outs. This is a Birmingham University spin-out. It's my first CEO gig. You have to speak to the academic founders and say, you've got this amazing technology. It's our USP, it's our IP, it's absolutely everything that separates us from anything else in the market. But you've got to bear in mind that nobody cares about our technology for the technology's sake. They want a product that they can consume, that they can wind into their existing processes, and it can provide them value. So how do we operate, and how do we deliver that as a process? And the technology is only part of that. It's how do they find out about the tech? How do they test it to make sure it's going to actually give them the feedback? How do they then, when they say, yes, this is good, how do they onboard it? How do we deliver it? How do we operationally support it? Because this technology has to be wound into a product that is deployable, supportable, maintainable, upgradable for the entire lifespan of the product when the product is with the customer. So you have to consider the product as a whole and how you're going to deliver it. And at an early stage of a company, you can do what I like to call the mechanical Turk, which is we as a company can do significant parts of, for instance, the onboarding and the operating. In the first instance, we'll put a deployment team out, and the deployment team will operate it. But we'll ask the customer, what area of ground would you like to survey? Maybe they'll draw it on a geofence. We will go away then, and we'll do everything we need to do, and we'll present them with the data, and then we'll provide the interpretation to that data. The customer has experienced our technology as it will be when it's fully finished, but we've done some of the heavy lifting in the meantime. Now, that's not scalable long term, but whilst we're still in the process of, why would I build a full operations team out when I can provide a very small number of people who can provide that value? And then when we start to scale and we actually got the product to market, we start scaling with customers, then we build out the operational support. Because it's one of the things that happened. And again, this is a story from Jaguar Land Rover. Like, there was 18 of us who delivered the product. That grew to 400 people very quickly, because the delivery of the product is not the goal. The deployment and the operation and the customer getting the value from the product is the end goal. And that is a completely different activity to building a company from the ground up and then delivering the products. Everybody sits back and goes, oh, we delivered the product. Right, great. We won the race to the start line. Now we've got to operate it and enable customers to get the benefit.
That's the curse of the prototype and the valley of death in U.S. acquisition. Yeah, got a great prototype. Well, and even software, you see it all the time where probably worst technology ends up winning because they've got the whole picture together. So the best technology just fizzles out and dies. So
it happens so often, Dave. It really does. You see these amazing things, and somebody's not, they've not patented it. They've not, done something wrong. They've been usurped by a larger player, or they've just not been able to articulate the value proposition, and they've not been able to turn something into, they've got a working product, which is a science experiment, and they've not been able to move that from that format, on that form factor, to something that's deployable. One of my first hires at Delta.g was a chief product officer. So he's a fractional guy, this guy called Nick Davey. He joined the business with experience of 13 years as CTO of a contract electronics manufacturing company. So during that time, he'd been taking prototype products through to small scale, medium scale, large scale manufacture. But then prior to that, he was product manager at Motorola. So the Motorola Razr, the little thin metal flip phone that you might remember, that was his product. So by bringing somebody in at a very, very early stage, what we've been doing is we've been looking at, here's the prototype. How do we take that prototype and how do we get it to a point where it is an actual consumable product? How do we make sure it's CE rated? How do we make sure it's DEFSTAN rated? How do we make sure we're actually building something that we can deliver to an end user? And what do we need to put in place? So as a company of less than 10 full-time employees, we implemented Arena PLM. So Arena PLM, Product Lifecycle Management System, so that we can start building out these bill of materials, we can start identifying supplies, we can start understanding, because of course, so much of it now with the political situation the way it is how do we make sure we've got secure supply chain? How do we make sure we've got sovereign supply chain? And how do we make sure we're protecting ourselves from people who may choose to just turn the tap off of parts and supply so that we are not able to make and distribute our products? So I went, and this was based on my experiences in previous deep tech startups, but also the previous startups I've been involved in.
Yeah, I mean, what a perspective. Well, to bring us together, quick high level, what other startups did you do? Because it's a fascinating background, a couple of clips on that. And then tell us about Delta.g. Why Delta.g? What problem were you solving? How did you know this came about? You said it was spun out of a university. Kind of bring us from your past startup companies after Jaguar to where you are now.
Absolutely, absolutely. So I left JLR and joined a 10-person startup who was creating an aftermarket connected car product. So we were partnered with Samsung, and we were delivering the product for AT&T. So we delivered that, and that taught us a lot about working with a large company like Samsung. Unfortunately, just before delivery of the device, the Note 7 debacle happened, and I don't know if you remember the Note 7, but it was the Samsung device that started bursting into flames. So the device was due to be given away with Samsung smartphones. It was respun, and we did release it, but it didn't have the fanfare that originally it was due to have. So I moved on from there, and I was doing consulting roles mainly on the operational side into startup and scale up businesses. And then about 7 years ago, I started getting involved in deep tech. So the former CEO at that company that I worked, so we delivered the product for AT&T with, called me up, and he was CEO of a company called Oxbotica at the time, an autonomous vehicle software company. They've since been rebranded as Oxa, OXA, and they've just closed their Series D funding round. So I oversaw the build out of the organization from 125 people to 340. And I was really putting the operational foundations in. I looked after everything from talent acquisition to HR, through to facilities, through to IT security, vehicle deployment, project management, and the interfaces to all areas of the business. So effectively making sure that we had the operational structure to be able to scale and to deliver to end customers. I then moved from there to a company called Oxford Quantum Circuits, a quantum computing company. Again, another spin out from Oxford University. And again, I joined the business, about 88 people there, and I was looking at putting those operational processes in place to enable the business to deploy quantum computers to co-location data centers, which we did in Spain, in the UK, and in Japan at the Equinix TY11 data center in Tokyo. So really, understanding the operational foundations of businesses. What attracted me to the role at Delta.g when I was up it, because at the time it was the only full-time employees were three academic founders, and they were still based in the University of Birmingham, but they had an extraordinarily mature product because of 10 years of research and £20 million of UK government public funding that had been put into the University of Birmingham. So we were spun out. We licensed some IP from the university at the time. But when we closed our £4.6 million, so that's about $6.5 million seed round in September last year, we had the IP assigned to Delta.g. So we now own the IP that we'd previously licensed.
Did you have to buy that from them, or did they just transfer it over to get the technology out?
They transfer it over. There is a notional fee, but I managed to get, they wanted a certain amount per patent, and I managed to negotiate them down to just that amount for all 3 patents. So it was a good deal for Delta.g. But to be honest, to be fair to University of Birmingham Technology Transfer Office or University of Birmingham Enterprise who run this, they are very, very committed to making sure that the spin-outs that they help to found are successful. They were super supportive with moving this IP out, and it was I can genuinely say it was a seamless process.
That's great. I mean,
it's not always the way. It's not always the way.
Well, pride, humility, I'd say greed, but just wanting a piece of the pie is tough, especially for universities that could really use that. So
they've got their eye on the bigger prize, which is they want more people to spin more technology out, and they want the world to benefit from this amazing technology that has been developed, as whilst it was in University of Birmingham, but then they want to take it and make sure that you can operationally deploy it and then make use of it. So their support's been outstanding, genuinely.
Amazing. Well, let's then talk about your company now that you've spun out. What are you doing? What's the pain points? Give me the rundown on why. Great product, you said, but what are its use cases? So just introduce us to Delta.g.
So Delta.g, companies today rely on outdated sensing capabilities to take high stakes critical decisions. We're still using technologies and techniques from they're decades old. We utilize quantum sensors to enable actionable real-time gravity data upon which you can take critical decisions in the moment for spatial intelligence and for navigation applications. So what we're doing is we're utilizing a sensor that can get real-time data that can take weeks with existing gravity solutions and get it in real time and provide that to a decision maker. We want them to have the confidence based on the data and the insights we are providing through that data to take a decision about something that needs to happen straight away.
So you are measuring changes in gravity. Is that correct?
We're measuring the presence or the absence of a gravitational signal to detect either the presence of something or the absence of something. Now, the reason I focus on the absence of something is void detection. So void detection, as you can imagine, has got significant impacts for dual use applications, finding tunnels. It's got applications within civil engineering, if you're finding voids or sinkholes beneath structures before you build. It's got applications for energy and natural resources when you're drilling to extract some energy or natural resources. Is there a void that's going to, destroy your $200 million drill when it hits it? So we've got these analogous applications across these different industries, and this is where we're looking to provide that value. So we're looking to provide certainty. So if we say something's there, it's there. If we say something's not there, it's not there. Just interesting, what we're not saying is that we have the one sensor to rule them all. What we're saying is that there's a lot of data out there already. Customers already have a significant amount of data. It's like there's a jigsaw puzzle with a big bit missing in the middle, and we're looking to provide the bit in the middle and then provide that data analysis layer so we can provide that data. So it's a data layer that you cannot buy for any money, wrapped with other existing data to provide unprecedented insights.
Well, let's go back to my knuckle dragon fighter pilot days. Isn't gravity a standard? Gravity changes when there's a hole in the ground?
So I'm not a quantum physicist. Nor am I a geophysicist or geoscientist. So I'm gonna, what you'll get from me is the layman's terms.
But I might understand that.
We measure it's microgal, so we're measuring these microscopic changes to gravity. So the way that gravity works, every single entity in the known universe has a gravitational signature. It's just, have you got a device that is sensitive enough? There's gravitational signature, there's gravitational pull between you and me now, but it is so minute that, we couldn't possibly measure it. What we're doing is we're utilizing these quantum effects to enable us to find these micro changes in gravity, which indicates either the presence of something or the absence of something. And by combining that and by taking the readings at different points, we can build 3D, 4D maps of the underground, and we can utilize it. We can bring it together with existing data to provide some really deep insights into what's going on beneath your feet. But the problem that we have at the moment with conventional sensing is that most of these sensors, and especially the gravity sensors, even quantum just gravimeters, because we are quantum gravity gradiometry. I'll explain what that is in a second. But they're exceptionally sensitive to environmental noise. So this is everything from talking to walking past to even in the UK. We're based in the middle of the UK near Birmingham. If we put a spring-based gravimeter down now, the waves lapping on the shore of the UK are many, many times the signal that we're looking for. And it's indistinguishable from the gravitational reading is indistinguishable from the environmental noise. So you would have to leave that sensor to settle for a long time. So you would understand, right, what's the background noise? What's the average of the background noise? And then you're looking for those microscopic changes. The technology that we have, it's the noise cancelling headphones for underground survey. What we do is we have two gravimeters on top of each other. And because they're quantum, they're based on rubidium atoms. So these atoms are identical, absolutely identical. We fire a single photonic laser, we make them as cold as space. So they're flying around the speed of fighter jets and they almost stop. We fire another laser pulse, they split into a quantum superposition. We drop them, we bring them together because both clouds of atoms have registered all the environmental noise at the same time. You bring them together and then eliminate that noise. And then you're left with this micro reading of gravity. And that is what we're looking to get. And that's how we provide the data.
Wow. So, all right. So, but you also mentioned there's data. So let's go to a use case. So we want to map the underground tunnels. I'll pick a place, Afghanistan, Is that something you would be used for example? Could it be used for?
Yeah, absolutely. Because what you're looking for is these changes in the gravitational signature. Now, it is the interesting thing to note about gravity is this isn't a straight down sensor. It doesn't fire a laser beam straight down. There's no reflected waves. We could encase this thing in 10 feet of lead on every side, and it wouldn't matter because it's not blocks by lead. This is gravity. This is a force of nature that we're measuring. So we could take it to hostile environments and we could package it in a way that it is transportable and it is usable within these environments. And we can find tunnels, we can find voids, we can find energy deposits, we can find aquifers, we could find things like this. But this technology has been, like I say, it's been 10 years in the making. We're just getting it to the point now where it's moving from TRL 6, where we're doing our own internal tests, and it's now operable for the very first time by non-physicists. And we're going to take it in Q3 this year. We're taking it onto customer sites and we're going to provide actual value. We're going to show customers this is how it can be operated, and this is the value that we can bring. So yes, it can, and we closed our £4.6 million, $6.5 million seed funding round in September last year. It was led by a company called Serendipity Capital, based out of Singapore, and they invest in dual use capabilities. We joined with a company called Science Creates Venture Capital, who were our pre-seed lead, but we also had investment from the UK government in the form of the National Security Strategic Investment Fund. So National Security Strategic Investment Fund, or NSIF as we call them, they make single investments into interesting technologies that are of significant use and deemed to be of significant use for the UK's defence. So we're working with them. And we've also, last year, we also applied for a competition with the US Department of Energy for some geothermal testing. Now, the administration change meant that the funding had been reallocated for that as well, but we got a notification that, it was something that was of extreme interest to US DOE. So we are in the process of, with the technology been recognized as having significant dual use capability. And we've had interest from these government departments, but then we've also got significant interest from energy and natural resources customers, mining customers. So we're having conversations with all those different demographics.
Fascinating. So just to help me again, it takes a lot. As we go, is this a device you set somewhere and it sits there for 10 hours, 100 hours, a month? Like what do you do so that you could deploy this where, let's say you're looking for, natural gas pockets, picking something, somewhere or something like that. How do you envision, because by the way, this does go right back to great technology. What's the product? What's the value prop to deliver it? So your whole story there, it now makes a ton of sense specific to your use case.
Yeah, exactly. So, I mean, look, this is the key. So the way that we think about this, the way we think about our whole system and our product actually is you can think of it roughly in three parts. So we've got this amazing quantum sensor along with all the control electronics and the laser system. It operates at room temperature, by the way. This is not superconductor. This isn't, you don't need, lots of super cold liquids. So you've got the control electronics, we've got the laser system, we've got the vacuum chamber. So that's one part of the system. Now you can think about that. You could put that on any deployment platform with testing. So at the moment, it is the baseline of the system is about that. But then when you put it on the deployment platform, it's about 1.5 to 2 meters long by about just over a meter high, something like that. But that's just on one application of it. It's on some tank tracks at the moment, so we can move it around and we can go over rough ground and so on and so forth. But if you think about the sensor itself and the control electronics is a reasonably small box that we can take and we can deploy. So we think about the system as the sensor system, but then a deployment platform. So today we're deploying it on the tank tracks, but we can put that on the back of a ute. We can put it on. It's been tested on the back of a Royal Navy ship. It's on any surface. So it's land or sea. We are looking at future drone applications of the system. So putting it onto a drone, and how does it measure? You asked. So at the moment we are move, stop, measure, but we measure very, very quickly. So it takes 200 milliseconds to take a measurement. So the way that we would survey an area to find that gas deposit that you were talking about, we would have the device on the back of a wheel platform, and we would move that wheel platform to an area. We would take a measurement. And what we're doing is we'd do what we would call a discovery scan. So we might take measurements every 100 meters. And we've got AI and ML telling us where it thinks we should be going next. Ultimately, this will be fully autonomous. So you can imagine it being on a drone and the drone just going around and taking the measurements where it needs to. Because what you're trying to identify is the edge of this anomaly that you're looking for. So we'd take readings every 100 meters maybe, and then we'd zoom in and say, there's something of interest over here because gravity is all around us, and we'd start to see that there's something over here of interest. And then we'd zoom into a detail scan, And suddenly we're taking detail of a particular area, and we're then looking to build up this picture and this image of what is beneath our feet. And that's what we'll look to provide. There's also, and I'll introduce this now because I always wonder when the right time to do this is, but we can find things underground based on their gravitational signature. If you can find something underground, you know where it is. If you know where it is, you can create a map. And if you can create a map, you can navigate without the need for GPS. So we have this, we're dual use, not just in the industrial defense sense, but this sensor has a secondary use, as in it can, and we can use existing bathymetric maps and LiDAR maps to identify, significant things that have a high gravitational signature and start mapping over them so that we can understand where things are. So you can imagine in future having a device that is on a subsurface platform that can not only detect what's around it, but can also understand where it is to a very high level of precision.
Wow. So really kind of the Google Maps, if you will, of, unknown.
Yes. So we've got, and again, it might be a good point to talk about this now, about the roadmap for implementation here and how, and again, I think you're sort of asking sort of based on previous experiences, how do I think about this? I think about things in horizons, and McKinsey were big on this, the McKinsey's hit 3 horizons, but I actually think of things on 4 horizons. So the horizon we're at now it's about proof of value for paying end customers. Do we provide insights via the data that you can't get for any money that provide them with significant ROI? And that ROI could be anything from saving time, saving money, saving resources, making people safer. However, we provide that value to the customer. And I'll harp on until I lose my voice about providing customer value. If we don't provide value, nobody's going to buy it. Nobody's going to buy this amazing technology. So I think about that as our first horizon, but then think about second, third, and fourth horizons. It's about getting into a specific entry vertical market and focusing on that, deliver the value through that, and make it. And you touched on it before. You've said that there's been some mediocre technologies that have become industry adopted because they were wrapped in a really, really good operational structure. The company was a joy to deal with, and their after service was fantastic. But what if we took an absolutely amazing technology and provided that level of customer service, and provided that a level of understanding of what a customer actually needs? And that's what we're planning. That's what we're aiming to do. So everything I've done at Delta.g to date has been in pursuit of building that cross-functional team. And we're now 15 FTEs, and we've got 5 fractional people. We have complete control of our end-to-end tech stack, everything from software, on device, on cloud, hardware build, hardware design, customer deployments. We've got that level of control so that we can do all things and we can move at the pace that we need to move at without relying too heavily on external parties. But what we do is so I'm a big fan of a book called Exponential Organizations by Salim Ismail and Peter Theomidis. And one of the things they talk about in there sort of really resonates with me from this experience I had at Jaguar Land Rover of getting this small group of people together. So you get a small group of people, cross-functional team, high agency. They're really, really going to, self-starters, go-getters. They're really, really going to push, and they're going to bring things stuff together. When you get them together in a room, they're all bouncing off each other. You've got physicists, you've got hardware engineers, you've got software engineers. They're all bouncing ideas, and they'll become way more than the sum of the whole, what we develop. So one of the things that Exponential Organizations talked about was get that core group of people together, and then use best-in-class partners that you can turn on and off, like manufacturing partners, third-party design houses, things like that, stuff that is not your core IP. Get really, really good partners to deliver that on time. And again, you don't have to hire them. So you can keep the core team as skinny as possible, but no skinnier. They can be creating that core IP and generating more IP, but then you're using these third parties. And at the right time, you scale. You choose the right time to scale. You don't do it ahead of time and get into a position where you're trying to raise a Series B or a Series D round, Series B, C, or D round with massive monthly burn because you've got too many people. You're always looking at, are my processes optimal so that my small group of people can actually work together and deliver what they need to deliver? Because people will come to you all the time. People come to me all the time saying, oh God, we're swamped with work, so we need some more people. So my first question is always the same thing. Do we actually need more people, or do we just need to change our processes? Because your processes evolve at such a startling rate when you're a small company. You become a new company almost every 4 to 5 months, especially if you're hiring. So minimizing that churn is something that is a goal. And I will always ask, right, you're saying you need more people because he's busy or she's busy. But I'm not just going to get another one of him and another one of her. I'm going to ask, actually, are we operating in the best possible way? Because if we need to reorganize and we need to change the processes and the way that we're delivering, we'll do that first before we just hire. And that's where using these external parties to turn on and off resource is really, really super powerful, because, you don't then carry the cost on the monthly burn cost of these heads.
Yeah, that's a great perspective for sure, because people are expensive.
People are expensive. And another key lesson is, without clear direction, people will just do stuff. They will just do things. And what you've got to provide is that crystal clear, this is the output, this is the outcome that we're all working towards. If anybody in the business, and I send these emails, I send quarterly objectives out, and I send emails out saying, if anybody is not aligned to these 3 objectives, or doesn't feel that their work is aligned to these 3 objectives, come and see me and speak to me, and we'll talk about how it either is and it's not immediately visible, or what else we can be doing to move things forward quicker. Because you'd be, and again, Dave, prior learnings, you would be amazed how many well-funded startups who've reached a certain point of scale have people on the ground who could not tell you how the work that they do on a daily basis contributes to the outcome of what the company's trying to achieve.
Yep, that's a dangerous spot to be in for sure.
Well, look, I mean, I'd like to ask you the questions. You've been in Lockheed, you've been, you've worked in these environments. I mean, what's your experience of building out these high performing teams? What's worked for you?
Yeah, I think the key is, it's similar to what you say, is when people run into struggles, and it's usually bandwidth, and that bandwidth is often, you can trace it back towards, being absolutely precise with what your objectives are and what to do. And so you'll find challenges or friction, and then was like, I can't get to my primary, directive, if you will, objective, because you're spending time with this noise over here. And so it's like, we need another body to take care of that noise. Instead of figuring out, why does that noise exist and how do we get that out through organizational process, tool changing, to refine that so that your folks can just be focused. I mean, we're dealing with it, we're in cybersecurity. We're dealing with these Silicon Valley, these crazy, they're doing what they call 9/6s. So, 9 a.m. to 9 p.m., 6 days a week. We're in Boulder, Colorado. We cannot compete with that. People actually have lives. I have a life. And so in order to succeed in this environment, when that's your competition, is we have to be extremely precise and effective in everything we do. If we spend time on something that's a little bit, off that very precise journey, we're going to get beat. And so and it's a challenge, because you are so in the weeds on process and details and objectives and clearing those roadblocks, but I think you have to do it to not bloat and get crazy and then slow down, because that's what happened. I saw it, seen it at Lockheed, big company. You've seen it at other companies. You get big. Big does not mean faster, and so it really starts to collapse on you. So I appreciate that.
No problem at all. Look, I mean, that's completely in line with my experiences as well. And again, I think the key is empowerment. Is giving those clear objectives and then saying, how are you going to do this? And something that I used before I read, again, I read a lot of books, but I read a book called Turn This Ship Around by David L. Marquet, who was commander of the USS Santa Fe, the submarine, which was the worst performing submarine in the US Navy. And they turned, and then the title of the book tells you everything. They turned it around to be the best performing. So we operate this process of I intend to. So David calls it the leadership ladder, and it's interesting. But you empower people to the point where they can come to me, or we do it on Slack. People who report to me will come to me and say, I intend to do this thing. I've thought about these 3 ways of solving this problem, and I've come to this conclusion. Do you agree? And I can give a green dot, and it moves, and the decision's taken. Or I can say, can we have a quick conversation for 5 minutes? I'd like to dig a little bit deeper into it. But we ripple that across the entire organization to empower the people within their zone of competence. So what are you competent to deliver? And then allowing people to say, I intend to do this thing. And it's about enabling the decisions to be taken where the information is the most recent and the most prescient.
Yeah. I could talk about this forever. Maybe we'll have another follow-up, because especially in startups, because you have founder mode, right? You have where you are micromanaging everything, because that by definition, you're getting things off the ground, and that the ability to transition then into leadership mode when you owned everything, like that's a tough transition for a lot of folks to make, especially technical founders, but really anyone, when you own something at the beginning, to give away those reins.
You've hit upon one of the key things I always talk to people about when I talk to other founders and so on and so forth, also in the business, is we're a very small number of people. You'll be across way more than your skill set actually is, what your skill set is. And over time, we will need people to focus, and we will need people to focus on these things. And some people cannot deal with it. They like being across everything. They will say, I'm absolutely slammed. Everything's happening at once. I don't know how to deal with it. And then you'll give them the power, and you'll say, okay, we'll back off and just take care of this particular piece. And then it'll be, well, I liked being involved in everything. And I like being across everything. It's a super difficult transition to make. Some people can do it, some people can't. And this is where, this is really the first point in the growth of an organization where you might start to lose people. And you might start to having to take a decision that this person is great for a 10 to 30 people startup, but they're not going to be happy focusing when it gets to 100 people. And they're certainly not going to be happy when it gets to a 200-person organization with global reach. And the job of work on a daily basis is the operational organization of the distribution of products and services. It's just a different beast, and it evolves over time, and it is difficult. It is difficult, but it's all part of the wonderful startup journey, and managing it is one of the top things a startup CEO needs to do.
Yeah, absolutely. Well, Tony, this has been a blast. Unfortunately, I gotta wrap it up, but breaking down quantum to a level that I somewhat understand, as well as what a great role and opportunity you have to make a difference in this world. So I applaud you for that. So if people want to follow what you guys are doing, how best would they do that?
They could look us up on LinkedIn. We are Delta.g on LinkedIn. They can follow me. I'm Tony Lowe, CEO on LinkedIn, and our website at the moment is delta-g.co.uk. shortly to become Delta.g.tech. So yeah, we're definitely going global with that. So no, Dave, this has been a blast and it's been great. It was great to meet you at the Tectonic event where we had some fantastic barbecue, and yeah, really great to follow up.
All right. Well, thanks, Tony. Appreciate it.
Take care. Cheers.